first question, we have an object that is rotating around twice every second. So that means that if it is rotating twice every second, we are actually getting the frequency, and that is going to be 2 Hertz. Now, frequency is equal to the inverse of period, so frequency is equal to 1 on t, so that means that our period t is going to be equal to 1 on 2, which is going to be equal to 0.5 seconds. In this one, we need to figure out how fast it's going to rotate before we can substitute that into our acceleration. Our velocity is the same as our speed in this situation because it is the magnitude, it's the tangential velocity. So our velocity is going to be equal to 2 pi r on t. The only thing is that our acceleration is a v squared relationship. So our acceleration is equal to v squared on r. So we can square our velocity and then plug it into the equation, which will get us that our acceleration is then going to be equal to 4 pi squared r squared on t squared r. One of those r's are going to cancel, which is going to be quite nice. So we get rid of that one and the square. Then we can just plug our numbers in. So we get 4 times pi squared times our 0.6 divided by our 0.5 squared, which should come out as being the 94.7 meters per second squared. From that, it's asking for the force, right? If we have the acceleration, force is equal to mass times acceleration. So we would just get F is equal to ma, which is equal to our 0.15 times by our 94.7, which is going to get us 14.2 newtons. In the second one, we are asked for 2 different situations. So it determined the minimum speed at the top and the tension force at the base. So we're looking in 2 different situations. One where we've got our object right at the top of the circle, and another one where we've got our object at the base of the circle. Now it's being held on a string, so there's going to be tension force, but what would be the minimum speed at the very top? If we look at this, our sum of the forces at the top, it's moving in a circular motion, so therefore the net force is going to be equal to mv squared on r. Any time that we have an object that is traveling in uniform circular motion, its net force must be equal to mv squared on r. If we want to reduce the amount of forces that are going to be applied at the top to its very minimum, what is the only force that needs to be there? Gravity. Every other force could disappear, but as soon as that object has mass, it will need to experience gravitational acceleration. So this is going to be equal to Fg, which is then going to be equal to mg. Our masses are going to cancel, but we're going to left with our v squared on r is going to be equal to gravity. So therefore our velocity is going to be equal to the square root of r times g, which is going to be equal to the square root of 1.1 times 10, which should be coming out as 3.317 meters per second, but 3.32 meters per second. An object traveling in uniform circular motion has the same tangential velocity. So that means the velocity at the top must be equal to the velocity at the bottom. So the sum of the forces in a uniform circular motion is equal to mv squared on r. At the very bottom, the net force must be pointing positively. It is on a string. So therefore, we're going to have a force that is pulling it up towards the center and a force pushing it down. And what's the down force? Gravity. So that means we're going to have a force of tension minus our force of gravity because they're pointing in opposite directions. We know what the gravitational force is going to be, but we don't know what the tension force is going to be. So Ft is then going to be equal to our mv squared on r plus our force of gravity, which is going to be equal to mass times gravity, which will get us our mass outside of velocity squared on radius plus our gravitational acceleration, which when we plug all our numbers in, should be coming out to be about 3 newtons.